Welcome everyone. Today we will be presenting our turning movement count lab. This presentation was created and prepared by Angel Vasquez, Jesus Gonzalez, Luis Gualderrama, and myself, Aaron Ruiz. For a thorough analysis of our turning movement count at the intersection of South Marietta Parkway Southeast and Cobb Parkway Southeast, our team used footage from our previous spot speed study, which took place on Tuesday, February 6th from 4 to 5:30 p.m. We then analyzed the footage to collect the necessary data. Afterwards, we collaborated with other student lab groups to share data from our given lane counts. This chart shows the number of lanes that are present in our given area of interest. There are a total of 5 lanes going northbound on Cobb Parkway, 5 lanes going southbound on Cobb Parkway, 5 lanes going westbound on South Marietta Parkway, and 4 lanes going eastbound on South Marietta Parkway. For our effort statement, all of our group members were present during the film portion of our studies. Angel extracted all the data from the videos and organized his results. I created the graphical summary of the data, Jesus wrote the discussion of our lab, and Luis the conclusion.
The results were calculated by adding the amount of vehicles that crossed each lane. These helped create the visual data summary, which shows the amount of cars using the designated lanes. The visual data summary can show us how traffic volume flows through the intersection during the data collection period. By taking the highest volume period and comparing it to the overall volume, we can find the peak hour factor. The peak hour factor shows us how spread out the peak hour is. If the peak hour is closer to 1, then the data remains consistent, showing the whole time period was busy. On the other hand, if the peak hour is lower, then there is a distinct peak hour in the data, meaning that there was a small period of time where the volume was higher. The percent of heavy vehicles was found by dividing the total heavy by the total volume of each intersection. Vehicles were considered heavy if they had more than 2 axles or were buses. For the most part, traffic flowed evenly in all directions. This is due to the fact that this is one of the busiest intersections in the area.
For the discussion, we wanted to visually represent the peak hour flows for each direction of travel. Keep in mind that our data was collected at 4:30 p.m. and ran through until 5:30 p.m. We have the northbound traffic, which starts with 327 vehicles and ends with 409 vehicles. 409 vehicles also happens to be the peak hour flow for this time period. Next, we have the southbound traffic, which starts with 319 vehicles and ends with 398 vehicles. 398 vehicles also happens to be the peak hour flow for this time period. Following this, we have the westbound traffic, which starts at 277 vehicles and ends with 370 vehicles. For this data set, the peak hour flow occurs at the time interval 5:15 p.m. with 395 vehicles. Finally, we have the eastbound traffic, which starts with 197 vehicles and ends with 242 vehicles. For this data set, the peak hour flow also occurs at the time interval 5:15 p.m. with 250 vehicles.
In conclusion, the traffic appears to be distributed evenly between all approaches. That being said, the traffic heading south and eastbound had a higher traffic volume of 1,386 and 1,358 respectively. In every approach, the straight right lanes seem to have a higher traffic volume with an average of 589 vehicles between the 4 approaches. When comparing the percentage of heavy vehicles in all approaches to the intersection, it seems to be evenly distributed with 2% across the board, with the exception of southbound approach on the Cobb Parkway having its heavy vehicle percentage at 1% of the traffic volume. As stated in our results, in the peak hour factor of northbound, southbound, westbound, and eastbound are 0.95, 0.93, 0.89, and 0.95 respectively. Now, the peak hour factor is used to convert the hourly traffic volume into the flow rate that represents the busiest 15 minutes of the rush hour. This can be calculated by dividing the hourly volume by the max flow rate. From these calculations, we get that both approaches, northbound and southbound on Cobb Parkway, are tied for the highest peak hour factor of 0.95. All turning volumes seem to be accommodated with a single signal cycle, even though it doesn't really feel like it when I'm late to class. Thank you for your time and attention. This concludes our turning movement presentation.